Okay, welcome back. In this video, we're going to go over how to do half reactions, identifying the oxidizing agent, the reducing agent, what gets oxidized, what gets reduced. You do not have this sheet. I apologize, but I'm going to post it right now. And then we will eventually get some homework on that. So let's take a look at it. It's actually this one. So this will be posted, so you can follow along and fill it in. I wish I had printed it, but it is what it is, I guess. Okay, so these are the actually the next step. These are the easier ones because the beginning ones, because they don't show you the full compound like this or like these. So these get more and more challenging. All right? So these are balanced for atoms. So we've got two chromiums, one tin and one tin. So it also has the oxidation numbers up here. So you can see that any any ion by itself, a monatomic ion, will carry its charge. So there's 4 plus 4, this is plus 3, and this is plus 2. Okay? So what's getting oxidized and what's getting reduced here? Well, what's getting reduced is the species, we say, the species which has its oxidation number decreased or reduced. So you can see tin goes from 4 to 2, so that's getting reduced. That means chromium is actually getting oxidized. It's getting oxidized because it's losing electrons. So here's chromium. Okay? If it loses electrons, the electrons are going to be on the right side. So we've got 2 chromium pluses, and we've got 2 chromium 3 pluses. So let's do some charge accounting here. Over here I've got 2 positives. Each chromide ion is what it's called. Each chromide ion has 1 charge, and there are 2 of them. So I've got a positive 2 over here. Each chromide ion on this side has 3, and I've got 2 of them. So I've got a positive 6 over here, and I've got a positive 2 over here. In order to even that out, I have to add electrons to this side. So this is losing electrons to become more positive. If I lose something negative, I become more positive. Okay, so how many do we need to lose in order for these 2 sides of the reaction to be electrically the same? So I've got positive 2 over here, positive 6 over here. I need 4 electrons. So 4 negatives and 6 positives makes for 2 positives. Okay, so that's how this half reaction would be balanced. How about the reduction part of it? I've got tin 4 plus, and then I've got tin 2 plus. Well, this is pretty straightforward. If I've got positive 4 on this side and positive 2 on this side, I need to add 2 electrons, which takes 2 positives away, essentially. So positive 4 and a negative 2 is a positive 2, and then I've got a positive 2 over there. So that is balanced electrically. Okay? Let's try another one. Let's try number 2. Any atom by itself or as a diatomic is going to have a 0. Let's see if I can change this. I'm not sure if I'm going to be able to. My guess says no. Okay, so we'll have to stick with it. Sorry. So this is a 0. That's a 0. It's a diatomic mercury, actually. And then charges of monatomic ions are the same as what they are. So, which is getting oxidized and which is getting reduced? Well, you can see that the mercury goes from a +2, +2, to 0. That's oxidation number goes down. So that's getting reduced. So we can put that one over there. 3 Hg's with a +2 each. I know on this side I'm going to gain electrons by adding them. And I'll leave this blank. What does it become? 3Hg2. Okay? Now, when we write those, we can write them as such. And this is going to be a 0. Okay? So, how many charges do I have over here? I've got 3 Hg2 pluses. +2 times 3 is +6. And over here, I've got 0. So, I need to add 6 electrons. 6 negatives, 6 positives equals a 0. So there's my reduced side. Oxidized. Okay, so what's left? We've got iron. Iron is going to lose electrons and become iron 3+. So what's my charge over here? 0 on this side, +6 over here. So I have to do the same thing. I'm going to add 6 electrons, 6 negatives, in order to counter the 6 positives from the iron 2 irons of a 3+ variety, iron 3. Okay? So really, that's as far as I'm going to go. We will be working through the rest of these over the next several days. Okay? You have your homework. You have a quiz due. And we'll go from there. So your oxidation reduction practice, the back, that is your homework. This is this one, I believe. Yep, I want you to do these 4. Okay? Take care.